So in today's video we are going to discuss about the chemical reaction. Okay, first of all, the chemical reaction is reversible reaction. Reversible reaction, which means one-sided reaction. Okay, not one-sided, sorry, two-sided. Yeah, two-sided reaction. Okay, what? Two-sided reaction. Okay, so if we talk about a two-sided reaction, which means it is having the covalent bond, just because of the weaker bond there is the two-sided reaction. For example, I'm having N2 plus 3H2 and NH3 is the, this is what, this is the reactant, and this is what, this is the product. Okay, and this is our reaction. So here you can see that the concentration, for example, is low, and this concentration is low. Reactant concentration is low, so the product concentration will be higher. Then the product will be occur. Okay, so after some time the reaction occur. Okay, many times the reaction will occur forward, backward. This is the reversible reaction. So after some time the reactant and product will be getting equal or balance or equal at an equilibrium state. That is called, which means the concentration will be getting constant. After some time the concentration will become constant. For example, if the concentration is low, the product concentration is high, the reaction will occur many times. After some time the concentration of both will become equal. Okay, so that we are calling as a chemical reaction. Okay, if we talk about the in the graph structure, if I'm talking about the concentration in the graph form, so this all the concentration is like this in the brackets form. For example, this is a graph. This is the time into the seconds, and this is the concentration in the mole per dm cube. This is what, this is the unit, mole per dm cube, mole per fraction, mole per liter, all are the units. For example, this is the reactant N2 and H2. These are the reactant. Okay, and this is the product, for example, product. So when the reactant is getting, concentration is low of the reactant, you can see that the concentration of the reactant is low, so that's why it is going downward with respect to the time, and the product is getting increased. So I can write here the product is getting increased like this. At some stage the concentration will become constant. Here you can see that these both are becoming constant. When concentration got constant, then there will be no variable in the, or no change in the concentration. Okay, so the concentration of the reactant and product will become equal. So this was about the graph that I have told you guys here, and this was the example. If I talk about the rate of reaction, what is rate of reaction? As you guys all know, in this, which means the concentration of both reactant and product are equal. Here the velocity of forward and backward, that is becoming equal, that is called the rate of reaction. For example, this was a product and this was a reactant. The both are getting equal. Both are getting what? Both are getting equal. So which means like this reaction is getting equal, the velocity is getting equal, that is called the rate of reaction. That is the difference between the concentration and the rate of reaction. If we talk about the characteristics of the, you can say that the chemical reaction, which means that this should be the isolated system, which means closed system in which the heat will be also released. So just because of the heat, the bond will be break. Because of the weaker bond, covalent bond will be break, and the reaction will become forward and backward. So that's why we are calling it a two-sided reaction. So it means this will be in the sealed form. Sealed system will be there in the chemical reaction. Concentration of the reactant and product will be constant. Okay, forwarding and backward rate will be equal. The temperature, pressure, volume, all should be constant. These were the characteristics. So this was about the chemical reaction.